Hi everyone, so for section 9.3 we're going to be looking at independent samples for two means. So independent samples are going to be when individuals in one sample do not dictate which individuals are to be in the second sample. So the best way, I guess, to kind of say this is there's no dependence here. Me selecting an individual for group 1 is not going to tie my hands on who I have to put into group 2. So the two different groups will give us a measurement for the same variable though. So we are going to both of those groups and we're going to be essentially collecting the same information or asking them the same kinds of questions. So for this video, we're going to just walk through the general steps for your hypothesis test using your Phantoms method, and then we're immediately going to start talking about the general steps that you take for your confidence interval, so your PANIC acronym. So for the hypothesis test, we always start by identifying our random variables and our parameter. So for example, x bar sub 1 is going to be the mean measurement of n sub 1 randomly selected objects from group 1. Again, the subscript of the 1 next to the n is just saying this is the sample size for group 1. Likewise, if you look at x bar sub 2, we are saying that we're going to be looking at the mean measurement of n sub 2 randomly selected objects from group 2. Your parameter, so mu sub 1 is going to be the mean measurement of all objects in group 1. And likewise for mu sub 2, that's going to be the mean measurement of all objects in group 2. So for our hypotheses, we would say something along the lines that mu sub 1 is equal to mu sub 2 for our null. In other words, we're saying there is no difference between the two groups. Another way that you could write that would be mu sub 1 minus mu sub 2 is equal to 0. You do not need to write it that way, and if you're curious, how did they get that? If we were to kind of come back to the original equality that I gave you here, if you subtract mu sub 2 from both sides, that would give us mu sub 1 minus mu sub 2 is equal to 0. So that's how we are getting that result. You can choose to write it as I have in purple over here on the left. So for our alternative hypotheses, we will either have a left tail, a right tail, or a two-tail test. So a left tail might look like mu sub 1 is less than mu sub 2, or again, if you want to write it as mu sub 1 minus mu sub 2 is less than 0, you can go ahead and do that. For your right tail, it'll be mu sub 1 is greater than mu sub 2, which would be mu sub 1 minus mu sub 2 is greater than 0. And finally, for your two-tail, we could write that as mu sub 1 is just not equal to mu sub 2. So mu sub 1 minus mu sub 2 is not equal to 0. Again, just to kind of really drive this home, any of the equalities or inequalities that I have written in the parentheses, you do not need to include those. Okay, those are just a different way of presenting your null and your alternative hypotheses. So now we're going to go through our assumptions. These should look somewhat similar to, if not identical, to the ones that we covered in section 9.2. So we do want to ask ourselves, are both simple random samples where before we were asking, are our samples dependent or paired? Now we are going to ask if our samples are independent of each other. So in other words, is my selecting someone for group 1 going to immediately force my hand on who I have to select for group 2? So for our third option, is each population normally distributed? Or is each sample size, you probably guessed it at this point, 30 or greater without outliers? And then we do have the caveat that if we are given data, we need to check out, we need to use our checks from section 6.4 to see if normality can be assumed. So that's looking at your histogram to see if you have a histogram that is roughly bell-shaped. You're looking at your box plot to see that you have at most one outlier and no more than that. And then also looking at your normal probability plot to see if the data falls on a roughly linear pattern. And then finally, do you know the population standard deviation, which remember, essentially, do you know sigma? Now we can go ahead and go through our assumptions. As always, we do want to ask for each group are both simple random samples. After that, we can ask ourselves, are the samples independent? If you look back to section 9.2, this step was, are the samples dependent or matched to each other? So really what you can do now that you will have gone through 9.3 and have already gone through 9.2, you can now just kind of adjust this question to ask yourself, are the samples independent or dependent of each other? Your third check is each population that your samples came from normally distributed, or is each sample that you're working with 30 or greater without outliers? So what you will need to do if you're given data, technically what you should do is you should go through your 3 checks that you have from section 6.4. So you should be checking to see if the shape of each group is normally distributed or bell-shaped. We should be looking at their box plots and making sure that neither one has more than one outlier. And then we should also be looking at their normal probability plots and asking ourselves if the data seems to be falling in a relatively straight line. And finally, for number 4, do you know the population standard deviations for each group? So you want to essentially know sigma sub 1 and sigma sub 2. Most likely, though, you probably won't know this information. So now that we've gone through our assumptions, and let's assume that everything looks good, this means that we're going to be able to name our procedure. And again, like I said, since you're most likely not going to know the population standard deviations for your groups, this means that you're going to use a 2-sampled t-test. Again, just to really highlight this, this is because you most likely don't know your sigmas. So now comes the time to calculate our test statistic. And as you can see on your guided notes, this is the grayed out area. So that means that your calculator is actually doing all of this work in the background when you are running your hypothesis test. But again, I didn't want to sweep all of this information under the rug. I wanted you to be aware of it so that you can appreciate what your tech is doing for you. And also, if you're interested in trying it by hand, you have that resource to consult. So for your sample statistics, we have x bar sub 1 and x bar sub 2. These are just the sample means for group 1 and for group 2. And then we would go ahead and take their difference, so the difference of those sample means. We also need to find the standard error. This is going to be the square root of your sample standard deviation squared from group 1 divided by the sample size of group 1 plus the sample standard deviation of group 2 squared divided by the sample size of group 2. So we take these 2 pieces of information, and that's going to help us calculate our test statistic. So x bar sub 1 minus x bar sub 2 is going to be subtracted from our difference of our population means. So again, if you refer back to your null hypothesis, this is where we said, well, mu sub 1 is assumed to be equal to mu sub 2, or we had also written it as mu sub 1 minus mu sub 2 is equal to 0. So what I'm noting here is that this subtraction of your population means is actually equal to 0. And this is why we've rewritten it over here on the far right so that it's just been eliminated, because we're essentially saying if we're subtracting from 0, I'm just going to condense this down. And then likewise, our standard error fits into the denominator of that test statistic. For the degrees of freedom in the lower right, as you can see, it looks very, very daunting. And I would say we definitely would be able to do this by hand, but we would need to be very, very careful with our order of operations in order to make sure that we didn't make a calc error. Again, your calculator is going to take care of that for you. So huge sigh of relief, I would say, at this point. So let's move forward. We're going to go ahead and obtain our test statistic and our p-value using our calculator. So the first thing that you would want to do is enter your data collections into list 1 and list 2. The main note that I would give you there is just make sure that you remember which group went into list 1 and which group is going into list 2. So maybe make a note of that on your paper as you're going through these tests. You do not need to create a third column for the differences in this situation because these samples are independent. They are not dependent. So from here, we're going to go to stats. We're going to arrow over to tests. And this is where we're going to select option 4, which is a 2-sample t-test. So once you've selected your 2-sample t-test, we are then going to either choose data if we were given tables of data, hence the reason why you would enter everything into list 1 or list 2, or we would select stats. And this is where we actually are given everything summarized to us. So if we are given everything in stats form, then we would enter in the sample mean that they gave us, the sample standard deviation, and the sample size for group 1, and likewise that same information for group 2. Then we would select our type of tailed test. So are we doing a right tail, left tail, or two-tail? And then we're also going to select, we have an option where it says pooled. And we are going to select no, because the only time that we would ever select the option of yes or the answer of yes is if we know the population variances are equal. And that should be explicitly given to you. If they don't state it, just assume that you do not know what the population variances are. And if you're kind of sitting there going, what's a population variance or what's a variance? Or maybe you're saying, that kind of sounds familiar. Remember that we uncovered variances when we were first learning about standard deviation. So remember that a variance is just the standard deviation squared. So after we run the 2-sample t-test, we are now able to make a decision about our null hypothesis because we will have access to our p-value now. So if your p-value, as always, is less than or equal to alpha, then we're going to reject the null and we're going to accept or support the alternative. And then if our p-value is greater than alpha, then we're going to fail to reject the null and do not accept or support the alternative. So from there, we will state our conclusion in the context of the problem. And as always, we're going to state the level of significance. We're going to state whether we reject or fail to reject the null. And then we're going to include context. So we're basically going to say is, for example, if we reject our null, we would then indicate is one group larger, smaller, or different than the other. Okay. If we fail to reject the null, then we would just say there is no difference between the two. So now we're going to go through our process for confidence intervals using the PANIC acronym. So I'm not going to spend too much time on this slide, but just as before, we're going to talk about our random variables and our parameters. And as you can see, they are laid out in exactly the same way as we had done prior in our hypothesis test. So moving right along, we will go through the same assumptions that we went through for the hypothesis test as well. Do we have a simple random sample? Are the samples independent? Do we know if the populations that the samples came from are they normally distributed, or do we have sample sizes of 30 or more? And remember, if we have sample sizes that are less than 30, then we need to go through our checks that we learned about in section 6.4. So looking at the histogram to see if it's roughly bell-shaped, looking at the box plots to make sure that we only have at most one outlier, and then also checking the normal probability plots to make sure that the data falls in a relatively linear fashion. And finally, do we know the population standard deviation for each group? Most likely, again, we won't know what the population standard deviation is, so that's going to prompt us to do a 2-sample t-interval. So your calculator will determine the confidence interval for you, but this slide is basically showing you the process that you would need to go through if you were doing this by hand. Notice that this corresponds with the grayed out section in your guided notes. So for your point estimate, that one I'm confident that you could easily do by hand. That would be your sample mean of group 1 minus your sample mean of group 2. Then we would also need to calculate the margin of error. That's going to require a critical value for your t, or your t critical value, and that's going to be dependent on the confidence level that you're trying to build, and then the degrees of freedom. So remember, if you look back to the hypothesis testing section, you can see we have a really cumbersome formula that we need to go through in order to calculate the degrees of freedom. But once you have that critical t-value, you will multiply that by the standard error, which is the square root of your sample standard deviation squared from group 1 divided by its sample size plus the sample standard deviation of group 2 squared divided by its sample size. So from there, we would take our point estimate, and then we would subtract the margin of error from it, and then likewise, we would also take our point estimate and add the margin of error to it. Again, your calculator will take care of all of this for you, but you do have this point of reference, and if you do have any questions about it, feel free to come to me about it. As stated before, everything will be taken care of in your calculator. In order to utilize your calculator to construct a confidence interval for two samples that are independent, we would go to Stat, arrow over to Tests, and we would select option 0, which is a 2-sample t-interval. So in this instance, remember that you are going to have to make the choice to let the calculator know if you are working with data or if you are working with provided summary statistics. If, for example, we are working with data, you're going to enter everything into list 1 and list 2 and indicate which lists the calculator should reference. Frequency 1 and frequency 2, you're probably going to leave these fields as 1 because you're not working with a frequency table. You would provide the confidence level in its decimal form. And then most likely, because you don't know the population variances for each group under pooled, you would select no as your option. Once you've entered in all this data, you would then click calculate and it would create the confidence interval for you. Whoops, sorry, I dropped the pen. Let me clean that up. There we go. So now we can state our conclusion. So this is where we're going to state our confidence level. We're going to note we are looking at the mean difference. We're going to use the lower bounds, the lower and upper bounds to cite the relationship of mu sub 1 minus mu sub 2. And this should match up with what you had worked with in section 9.2. So if both the bounds, so your lower and upper bound of your confidence interval, are positive, then mu sub 1 is bigger than mu sub 2. If the bounds are both negative, then mu sub 1 is smaller than mu sub 2. And if the bounds contain 0 in there, then we cannot conclude the relationship between mu sub 1 and mu sub 2. And for the umpteenth time, include that context in your final statement. So we're going to go ahead and we're going to move into an example problem next. Make sure that you're taking some good notes, and after that, I will give you a practice one to try on your own. Okay, so in this example, everyone, we have Elijah wants to know whether textbook costs are different for different courses of study. He selects a random sample of 33 sociology textbooks offered on a popular online site. The mean price of his sample is $74.64 with a standard deviation of $49.36. He then selects a random sample of 44 math and science textbooks from the same site. The mean price of this sample is $111.56 and with a standard deviation of $66.90. Is the mean price of a sociology textbook lower than the mean price of a math or science textbook? Test at a 1% significance level. So in this situation, we don't have data to enter into the calculator. We have summary statistics. So that's kind of good to note. Group 1 is going to be, in this instance, I'm going to have Group 1 be my sociology group, and then Group 2 will be my math science group. So starting on a fresh slide, we can go ahead and start identifying our random variables and our parameters. To help myself out, I am going to remind myself that Group 1 I'm saying is sociology, and Group 2 will be my math and science. So for my random variable for Group 1, so x bar sub 1, this is going to be the average cost of 33 randomly selected sociology textbooks. So x bar sub 2, there we go. This will be the average cost of 44 randomly selected math and science textbooks. So notice here that the two groups don't have to have matching sample sizes. It's okay if they are different, so do not panic when you come across that. So now for our parameter, mu sub 1 will just be the average cost of all sociology textbooks. And mu sub 2 will be, you guessed it, average cost of all math and science textbooks. Now we can talk about our hypotheses. So our null, we're saying that there is no difference between the average costs of these two groups, or these two subjects. So mu sub 1 is equal to mu sub 2. Our alternative is where we kind of bring in that seed of doubt. So this is where we're asking ourselves, am I doing a left tail, right tail, or two tail test? In this instance, since I am having Group 1 be sociology, and I did ask myself, or this question asked me, is the average cost of the sociology textbook cheaper than the average cost of the math and science textbook? We will go ahead and we will do a left tail test. And then I'll also call out that my level of significance is going to be 0.01 or 1%. So now we can go through our assumptions. So we want to ask ourselves, do we have a simple random sample? And that answer is yes. We have that clearly stated in our narrative. The next thing that we want to ask is, do we know if the populations are normally distributed? Or do we have sample sizes that are greater than or equal to 30? And in that instance, we would say yes. And we can clearly see that in our definitions for our random variable. We have sample sizes of 33 and 44, so we're good there. Now we want to know, do we have independent samples? And I would say yes. There's nowhere in there that's saying that because I picked a certain sociology textbook that I was forced to pick a very specific math or science textbook. So we're not kind of saying like because you picked this publisher, you have to also pick a a math or science textbook from the same publisher or something like that. We're just doing random selections for both of them. And then finally, we want to ask, do we know sigma? And in this case, we would say, nope. We have the sample standard deviations. Okay, so because we don't have the population standard deviations, this allows us to name our test that we're going to do, and that's going to be a 2-sample t-test. So from here, we need to jump to our calculator in order to get our test statistic and our p-value. So let's go ahead and jump to our calculators and go through this process. Okay, so let's go ahead and conduct our 2-sample t-test. So we're going to go to Stat. We're going to arrow over to Tests. Again, we don't have to enter data in this case because we were provided the statistics already summarized for us. We don't have any data to enter into the tables. So we're going to go all the way down to option 4, which is our 2-sample t-test. And I'm going to switch this over to Stats. And then I'm going to enter in, remember group 1 was all of our sociology textbook information. So the sample mean was $76 and nope, $74.64. Reading comprehension is an important and powerful skill, everyone, just as I demonstrated with my error there. My standard deviation was $49.36. And then the sample size was 33 textbooks. Moving to group 2, which was our math and science group, that had an average cost of $111.56 with a standard deviation of $66.90. And then we had a sample size of 44. We were interested in doing a left tail test because we said group 1, which was our sociology, should be cheaper or cost less than group 2, our math and science group. Notice that in this narrative, we were not provided any information about the variances for the population. So we're going to assume that this is not pooled. So we'll go down, we don't have to worry about color, and we're going to go ahead and calculate this. So we get a t-score of negative around 2.79, and then a p-value of roughly 0.003 if I choose to round to the 3rd decimal place. And you can see all the information that they provided for you here. So here are your 2-sample means, the sample standard deviations that you entered in, and then your sample sizes. So it's just kind of regurgitating the info that you had already entered in. So let's hop back to our notes, and we will go ahead and make our conclusion. Okay, so we have our test statistic and our p-value entered into our notes now, and we can now go ahead and make a conclusion. So this is where we're going to take our p-value and we're going to compare it to our level of significance. So our p-value is 0.003, or roughly 0.3%. And our level of significance we said was 0.01 or 1%. So as we can see here, 0.3% is less than 1%. So this means that we are going to reject our null. So now we can state our conclusion. And we would want to say something like at the 1% significance level, we reject H sub O. We have sufficient evidence to support the claim that the mean price of sociology textbooks is lower than the mean price of math and science textbooks. And there we have it. So now we're going to roll right into our confidence interval question. So we want to find a 95% confidence interval for the mean difference in price between the sociology textbooks and the math or science textbooks. So we'll use our PANIC acronym to help us keep this organized. So we want to identify our random variables and parameters along with checking our assumptions. And we've actually already done all that work, so I'm just going to note these as done. We did this in our work for our hypothesis test. So we can move right on down to naming the type of interval that we're going to work with. And here we're going to work with a 2-sample T interval. So 2-sample because we already know that these are 2 independent samples. T because we do not know the population standard deviations, and interval because, well, we're doing a confidence interval. So that one hopefully isn't too bad. So now we're going to jump into our calculator and enter in all that data to construct our interval. So follow me over to the calculator. Okay, so to run our 2-sample T interval, we're going to go to Stat, arrow over to Tests, and we have to scroll all the way down or select option 0. So here's our 2-sample T interval. We are going to work with statistics still because that was what was provided for us in the narrative, not data. So good news is that it did kind of copy and paste everything that we had already done when we were doing our 2-sample t-test. So we've got our sociology info in group 1 and our math and science info in group 2. And we want to do a 95% confidence interval, so I don't have to change that. Again, we don't need to pool any of the data. And then we are going to go ahead and calculate. So essentially what this is saying is that a sociology textbook is anywhere between $10.53 cheaper all the way up to $63.31 cheaper. So we're going to carry this info over, and then we will go ahead and basically formally present our findings in a sentence. So I will see you back in the notes. Okay, so now we can note our interval. Our interval, we said, went from negative 63.31 to negative 10.53. So let's go ahead and state our concluding statement. So we are 95% confident that the true average cost of sociology textbooks is between $10.53 and $63.31 lower or cheaper than the average cost of math and science textbooks. Okay, so it's your turn. We're going to go ahead and take a look at an example for you to try. Make sure that after we read through the problem, you pause the video and work through the solution before pressing play. So our example reads, the number of cell phones per 100 residents in countries in Europe is given in table 9.3.9 for the year 2010. So just to jump over there really quickly, and this is also located in your guided notes, each of these cells represents a small collection of 100 residents, and we asked them how many cell phones they owned, so we have the total. So in instances where, for example, you see someone who has like 100, or you see a group that has 118 cell phones, that must mean that some people have multiple cell phones. So think of it as like personal and business or something like that. Continuing on, the number of cell phones per 100 residents in countries of the Americas is given in table 9.3.10, also for the year 2010. Is there enough evidence to show that the mean number of cell phones in countries of Europe is more than in countries of the Americas? Test at the 1% level. So go ahead, take a moment and work on this hypothesis test utilizing your calculator. So again, you have data this time, so you are going to want to make sure that you identify your group 1 and your group 2. So for example, since they gave us Europe first, I would consider Europe group 1, and then I would consider the Americas as group 2. You will want to enter those into your table in your calculator. So go ahead and get started on this, pause the video, and when you are ready, press play, and we will go through the solution. Okay, so let's go ahead and look at the solution here. So first we'll identify our random variables and our parameters. So I considered European residents group 1 and then the American residents as group 2. So x bar sub 1 is going to be the average number of cell phones from 53 samples of 100 European residents in 2010. And x bar sub 2 is going to be the average number of cell phones from 39 samples of 100 American residents in 2010. Our parameters then will be the average number of cell phones for European residents in 2010 for mu sub 1. If you wanted to, you could say all European residents. And then mu 2 would be the average number of cell phones for American residents in 2010. Our null and our alternative. So again, the null is assuming that there is no difference between the two groups. So this is why our null is just going to be mu sub 1 is equal to mu sub 2. Our alternative, here we're claiming that the European residents have a higher count of cell phones on average. So we're going to do a right tail test here and have mu sub 1 be greater than mu sub 2. And again, we're going to use a significance level of 1%. Looking at our assumptions, we are assuming that we have a simple random sample. Do we know if our populations are normally distributed or if we have sample sizes that are greater than or equal to 30? Yes, in this instance, we know that we have sample sizes that are greater than or equal to 30. Are the samples independent? So I would say yes, because it doesn't seem like us selecting residents in Europe forced us to pick specific people in the Americas. Also, do we know the population standard deviation? That's a big nope here. So that informs us to do a 2-sample t-test. So because we had some data entered, I'm going to go into the calculator. So bear with me. I will jump over there in just a second. Okay, so we're going to enter our data into our calculator. To save time, I went into stat and I've already edited my lists in. So you can see that I've already entered in all of this data. So the main thing that I would caution you with, because this is a little bit more, but this is also a practice problem, just make sure that you've entered in all the data correctly. So if you find that your answers are a little bit off than mine, just double check your entry to make sure that everything is okay. So from here, we'll go to stat, over to tests, and we want option 4 for our 2-sample t-test. I've already got it selected on data this time. So list 1 will be my European group that I entered in list 1. List 2 will be my Americas group, which will be in list 2. I don't have any frequency tables in this situation, so I'm going to leave these as 1. And I did want a right tail test. If you go back to your alternative hypothesis, we had that mu1 was greater than mu2, assuming that your group 1 is Europe and the Americas is your group 2. We don't know the population variances, so we're going to mark this as no for pooled. And we're going to go ahead and calculate. And we should get a t-value of roughly 3.00 and a p-value of about 0.002 if I round to the third decimal place. So let's go ahead and drop that into our notes, and then we will make our conclusion in our statement. Okay, so I've logged our test statistic and our p-value. Now comparing your p-value to your level of significance, or your alpha, we can see that the p-value is less than 1%, so therefore we will reject our null hypothesis. So this leads us to the following statement. At the 1% significance level, we reject the null. We have sufficient evidence to support the claim that the average number of cell phones for European residents is greater than the average number of cell phones for American residents. So now we want to ask, well, what's the 98% confidence interval for the difference in mean number of cell phones per 100 residents in Europe and the Americas? So if you haven't already, go ahead and pause the video to work on this one, and then when you're ready, press play. Okay, so remember going through this process, naming the random variables and parameters and checking your assumptions. That was already done, so you can kind of pull what you had already done from your hypothesis test. And then in this instance, we would do a 2-sample t-interval. I'm going to briefly go through the calculator process with you, so I will kind of jump over to that. So jumping back to the calculator, we will go back into stat, arrow over to tests, and we want option 0 for our 2-sample t-interval. Again, this time we're working with data, so we are going to have it pull from the same list 1 for our European group, and the same list 2 for our American group. We don't have any frequency charts or frequency tables here, so we just leave those marked as 1. We do want to change this to 98, though, because that's what the question asks. We want a 98% confidence interval in this situation. It's still going to be a no on the pooled. We don't know the population variances. That information wasn't shared with us. And we're going to go ahead and calculate. And here we go. So we've got our confidence interval above. So we can note here that the European group has between, I would say, like 4, if we are using our rounding rules, to 38 more phones per 100 individuals. And then below you have the rest of the information, your degrees of freedom, your sample means, your sample standard deviations, and your sample sizes. Okay, so let's pull this information back into our notes and make our final conclusions. So I've pulled in our information from our calculator, and we would state or summarize our interval like so. We are 98% confident that the average number of cell phones per 100 European residents in 2010 is between about 4 and 38 more than the average number of cell phones per 100 American residents in 2010. Again, in this situation, I chose to round to the nearest whole number because no one has a fraction of a cell phone on them. They either have one or they don't. So we went ahead and I used my rounding rules to get between 4 and 38. And this is also why I included the word about in my description, to kind of remind myself that I did do some rounding here. All right, so that completes lesson 9.3. If you have any other questions, please let me know. If not, have a great rest of your day.